So welcome to today's webinar, Navigating AI and Data. I'm really happy to be moderating this event for you today. I'm just going to go quickly through a couple of housekeeping points and just give you a little bit what's in store for you. First and foremost, I want to talk a little bit about the agenda today. So Mike will speak a lot about the technical aspects of AI and data and go very in detail. The presentation is absolutely great. I really learned a lot with that. I'm very excited for him to present that to you today. Then just to make sure that you're not falling asleep, we're doing a poll. So we'd like you to participate in the poll in the middle. This gives also Nick a chance then to prepare. And he has some real use cases. So then not just talking about the technology, but also showing how clients are able or have already enabled using AI and data. Then at the end, we do all the Q&As, all the questions which you can put in the chat or in the Q&A. And we also have a survey because we want to make sure that the webcast is relevant for you and is good for you. And if there are other topics you want us to cover, then please, let us know that as well. So that's in the survey. We have a ghost in the machine, which is Lucia. So if it's not me responding in the chat, it's Lucia helping us. Doing HI, human intelligence, rather than AI. And she just said hi very quickly into this. And then with no further ado, let me introduce our great two speakers today. So first and foremost, thank you very much, Mike Ferguson, to join us. He's the CEO of Intelligent Business Strategy Limited. He's an independent industry consultant. He's over 40 years experience. He's hugely successful in big data, AI. He is chairman in the Big Data London, and we're very, very honored to have him here today. And he will start with the first presentation. So welcome, Mike. I'm really looking forward to hearing that.
Thank you, Tommy.
And then, last but not least, of course, Nick. Nick is the CEO of Data Virtuality. He's been founder. He worked on the client side previously, so he's got vast experience in that field. He's been around for more than 15 years in this area, and he will be talking about some of our clients and how they use AI and data. And I'm very, very proud that he also is part of this presentation today for you. There is always the person who speaks most. That's always the salesperson, and that's me, Tammy Coles, and I'll be the moderator for you today. So with no further ado, Mike, please take it away.
Okay, thank you, Tammy. So good afternoon, good morning, good evening, wherever you may be. Thanks for taking time to come to this session. So I want to talk to you about what's happening in our industry today around AI and of course data. And in particular, I want to look at, of course, the hype, the phenomenon around AI right now and executive expectations, kind of look at the types of AI that are out there and try and match that to business case usage and kind of examples of applications that are suitable for different kinds of AI. And then look at the dependency that AI has on data and high quality integrated data being important. But then look at the challenges companies have in trying to create that kind of high quality integrated data, what the requirements are. Do you have to kind of overcome given these challenges, and how you can go further and use AI to accelerate the ability to create data for AI. So let's get started. So I just thought I would look around for some definitions of artificial intelligence to get going. I went to Wikipedia, of course, and you can see here that it's the intelligence of machines or software as opposed to the intelligence of humans or animals. If I look at the SAS Institute in the middle, just as an example of a vendor, they say it's making it possible for machines or software to learn from the experience, adjust new inputs, and perform human-like tasks. And I think the same is true for the bottom quote as well. So as you no doubt have seen, it's everywhere right now on every website. Everyone's talking about it. Press releases I get at the moment as an industry analyst are just dominated by the whole AI seen. And to some extent, generative AI is kind of drowning out almost everything else. But as we'll see in a second, that's not the only type of AI kind of out there. But without doubt, the executive expectations are enormous right now. Really huge expectations as to what data and AI is going to do for business, and that's reflected in some of the surveys out there. This is an example of one of those surveys, which clearly shows that in 2023, despite the tough economy, um, companies are increasing their investment in data and AI. And that's because they're getting measurable results. As you can see, almost 92% of companies surveyed in this particular survey stating that they got measurable results. And that number is projected to go higher next year. So a real appetite, if you like, for increasing investment in this space despite the tough economic times. But there are clearly different types of AI, and you know, we're not just looking at one thing which is grabbing headlines right now, which is generative AI. I mean, clearly what we have here is, you know, supervised and unsupervised machine learning, you know, supervised to predict um, things or make recommendations, unsupervised to identify patterns in data that's found there. Um, Natural language processing as well, again linked to large language models, but has been in existence long before large language models emerged. Deep learning, which is out there as well, often being looked at in the context of images or video, for example. Reinforcement learning, which you often see with self-driving cars, or to do with gaming, and also to do with a new space, which is to do with planning right now, which is gaining a lot of attention. Um, and then, of course, AI automation. So things like building AI bots to do things, whether that's to do for customer service or to do for something like intelligent document processing, where you can process large amounts of, I don't know, loan applications, for example, or and of course generative AI. And if I look at it as it stands at the moment, I would say vast majority of my clients, at least, are well practiced at implementing supervised and unsupervised learning. I would say that's, you know, a lot of people have got machine learning models built using that kind of capability. And I think it's fair to say today that, you know, most companies are still experimenting with generative AI, albeit that some more leaders in respective vertical markets may already be in production with some of that kind of capabilities. But that's still unfolding. If I take a look at classic supervised learning, then what you get here is the whole idea is you give a training data set to an algorithm to train it. So, for example, if you want an algorithm to predict customer churn, then you give it examples of customers that have already churned. Similarly, if you want to predict a failure in equipment, then you give it data which is symptomatic of a pieces of equipment that have already failed. And so you train the model to recognize these things, and you go around that loop several times, and then when you're happy that's accurate, then you can deploy it on the real data, so to speak, and then have it be able to make these kind of predictions. So in the case of customers, are they going to churn, or do you predict that they're not going to churn? So that you can then focus on customers that are likely to perhaps leave if you want to keep them. And all kinds of examples of supervised learning out there, whether it's customer focused related, such as uh, propensity to buy and next best offers, or whether this is to do with efficiency and optimization, such as preventing pieces of equipment failing in a production line. But we can also deploy those kind of supervised learning trained models in real time to monitor live events that can affect our business and cause near real-time actions to try to prevent risk happening or to take advantage of opportunities. And so this is a kind of an example of a workflow where you could see streaming live data on the left-hand side, maybe along with some data that's already stored. You're going to filter that out, feed it into a trained model, have it make predictions if something's going to happen. And you could then drive recommendations and alerts to people, or you could even cause totally automated actions on the back of that to keep a business optimized or to prevent unnecessary, unavoidable risk. And all kinds of use cases for this. This is from different vertical industries, just a few examples of cases where you would use that to prevent things happening, such as fraudulent transactions in a financial services, or network outages in a telco, for example, or machine failures in a manufacturing. You want to prevent that. On the other side, optimizing, to do dynamic pricing, for example, um, to do personalization on a website so that customers get a very personalized experience, or to try and optimize the supply chain. So these are all examples of that kind of machine learning, supervised machine learning. Then there's unsupervised, and of course, unsupervised, it doesn't rely on training a model. You give it the data, it finds patterns. For example, similarity or outliers and things like that. And you can see here, one of the most popular use cases for this, of course, is customer segmentation, where you feed your customer data into for unsupervised learning, and what you get back is customers that are grouped together based on similar characteristics or patterns in the data, and then you can go ahead and maybe focus on a particular customer segment and do targeted marketing campaigns, for example, for them. So all kinds of use cases here, whether you're trying to classify a customer to say that they're likely to buy or they're not likely to buy, or you're trying to segment customers for more accurate marketing, or trying to do market basket analysis so that if people buy one item in a retail store, they're highly likely to buy another. So you would put them together on the same shelf space, or even if there's a time lag between them. So if somebody buys a mortgage, then they're highly likely to buy property insurance, and so but there may be a delay in between. Or you're trying to find an outlier, like fraud, for example, which would be another example of what I would call an outlier. Deep learning, as I mentioned, very much came to the fore around things like facial recognition, um, uh, uh, protecting you from unsafe content, for example. This kind of thing, also able to pick things out of images, or to create captions to explain an image. Very popular. These are multi-layer neural nets, which again have also been applied to structured data. And then also AI automation now getting attention, as you want to put bots in to undertake very repetitive tasks mundane tasks in processes, replace humans by bots to speed up the execution of a process. These are all examples. And then, of course, there's the kind of new kid on the block, which is getting all the attention right now, which is generative AI, which was kind of brought to public attention, I guess, back in about February timeframe when we saw the emergence of ChatGPT. And these are, again, multi-layer neural nets that are trained on vast amounts of public content, and they are designed to generate content, whether that be text, it could be code, it could be synthetic data. You can have a chat experience with that. Could even generate images or video. And we're seeing that changing employee and customer experiences and applications, improving productivity, and increasing the amount of automation going on. And there's a whole slew of models, large language models, that have appeared since GPT, of course. Now we have some of these examples that I have on the slide being used, again, from different vendors who've trained these on enormous amounts of public content. And there are some issues with these, like people talking about them being, giving hallucinations or just generating things, even if they don't know what to generate. And we can take action to prevent that kind of thing happening. But you can use a large language model to as it is, just without doing anything, or you can fine tune it so you can give it additional data. and go through a fine-tuning process straight off of a data science workbench to be able to do that. And once you've got your fine-tuned model, you can deploy it as a service and then have other tools or applications just call it, pass over a natural language prompt and get generated content back, whatever that is. It could be text, could be a blog, could be a tweet, could be code that you want to use. There's all kinds of use cases for this. Could be descriptions for data catalogs, all kinds of use cases. And another way of doing this is using something called embeddings, where you can take your data or your metadata and break it up into chunks and pass it through algorithms to create something called vectors. Vectors are just numeric representations of that data, which can then be held in a vector database. You can just, when you do a prompt, it passes over similar things that it finds in the vector database. And the idea behind this is that it reduces the amount of chance of you getting what's called a hallucination back in the response from the generated content, and it makes them far more accurate. And this is kind of widely practiced now, is seeing more and more of this happening out there. In terms of surveys out there, well, what are people thinking about using generative AI for? Well, here's an example of one done this year, saying that automating IT processes was the #1 issue, followed by customer service and then supply chain. I've got a few examples on the screen here of marketing, sales, and service, where you could use a natural language prompt to speed up your ability to do things. For example, if you're in marketing, to generate blogs or to generate a web page for people to register for a webinar like this one. All kinds of use cases like this emerging. And another survey, which was published just back in June in Fortune magazine, showing that again, 4,000, or no, I don't know how many CEOs on this one, but saying that, that they are very likely to be using generative AI again to improve efficiency, to automate manual operations, make people more productive, and to lower costs, and maybe also to speed up their ability to capture data. But of course, all of this relies on high quality data. You can't have these huge expectations and expect to be data driven and have AI automation if you don't have a high quality, governed data foundation. And the problem with that, of course, is that most companies don't have a high quality data foundation. What they've got is data scattered across a distributed data estate. They've got data in software as a service applications. They've got data in multiple types of database on multiple clouds or on premises, or they may even have data streaming in off the edge or even stored at the edge in edge database. And so all kinds of different data stores out here, NoSQL databases, file systems, cloud storage, relational databases, they're all out there. And that's the challenge that companies have. And of course, that makes it harder to find data for AI. And it's harder to manage it. It's harder to govern it. It's harder to integrate it, and slows the process down when what we're trying to do is speed it up. Because clearly, the sooner we can deliver the kind of models that come out of AI, the quicker we can get them into deployment, speed up the pace of our business, and be much more responsive and much more competitive in the markets that you operate. But what you also don't want is everybody just kind of like with their own tools and saying, yeah, just give me data, grabbing it from anywhere, because there's absolutely no guarantee that this kind of situation, first of all, turns into the Wild West. Secondly, could result in all kinds of inconsistencies. And the other problem is if everybody's using different tools to do this, whether it be data science tools or BI tools with self-service data prep or standalone data preparation tools or code or whatever it may be, you end up with everybody's got their own island, just their own silo, pulling in data from various sources. And because there's no standards to share metadata, we end up with people not knowing that other people have already done this. And then you ask how many times have you taken the same data from the same sources for different individual users with different tools. And then you begin to realize, well, actually, this could breed inconsistent data and multiple versions of data. And you can't build trusted, high quality AI models on the back of inconsistent data. I mean, it's just defeats the object. You're going to get inaccurate AI as a result, which makes it, not valuable. So it's unacceptable to get biased and poor quality data into AI because what you're going to get is inaccurate predictions, inaccurate recommendations, hallucinations in generated content, et cetera, et cetera. What we really want to do is prevent that, make sure we've got bias removed, and in order to get accurate predictions and recommendations and high quality generated content. So what are the requirements therefore to be able to do this? Well, one of the key things that's going to accelerate this is rather than build monolithic data models for individual analytical systems and do that for each kind of analytical system or every single machine learning model, then what we really could do is how do we speed it up? And by far the thing that's getting attention right now is to build data products. Now, I've been quite clear on this screen as to what I mean by data products, because there's all kinds of definitions of that floating around. But if you would be kind enough to, at least for this presentation, to accept my definition, which is data products are either physical data sets, or so they're persisted, or they can be virtual data products, which could be persisted later. That's okay. They don't have to be. Providing integrated data that's high quality and available for use. It's ready to go. Or it could be the metadata, which is the pipeline effectively, which is invocable by an API. And when you invoke it, it's going to render the data product. But what I'm not saying is that a BI report or a machine learning model or a recommendation engine or an AI bot is a data product. What I'm saying is they're analytical products, and they are produced by using data from data products. And so that's the distinction that I've made here. So if you'd be kind enough to accept that as a definition, then the big difference with data products is we're not integrating and cleaning data for a destination system like a data warehouse or a graph database or for a machine learning model. What we're doing is building reusable data building blocks. These are publishable, ready to go, cleaned, high quality data sets which can be, again, physical or virtual, for example, that are just going to give you one thing. And you can publish these in a marketplace and allow consumers to come in from the right-hand side and pick what they need, whether it's for a data warehouse or a graph database or a machine learning model or to access directly from a BI tool. That's okay. But what they're accessing is ready-made. And even as we modernize the architecture, and it's pretty clear that's also going on, as we start to combine things and integrate different kinds of data store and reduce down the amount of copies of data, we still are able to use these reusable data products to support multiple analytical workloads. It's just that the difference now is that, where we might have been doing machine learning on one type of data store and data warehousing on another, and streaming analytics on another, now we're beginning to see that we can potentially do these on the same architecture, and potentially even on same copies of data. But nevertheless, data products are decoupling things. And what we're seeing is, can we democratize data engineering and have some kind of software platform that can connect to all of our underlying data sources, catalog what's out there so that we know it exists, and then allow multiple teams to produce data products to clear a backlog that IT maybe can't keep pace with business. And then we've got all of that. We can speed it up, get the experts who understand certain kinds of data to define what is a customer, what's an order, what's a product, so that we can create the definitions for these, in a glossary within a catalog. We can then discover where is the data for these data products that we want to build across that distributed landscape. And then from there, can we build the pipeline or the metadata specification that then gets that data from the sources and and produces the data product that we've defined and make it available for people to consume and use. And so what we're now seeing is data marketplaces are becoming the place for the consumers to go shopping for data. But as you can see here, it's not just physical and virtual data products. We're beginning to see even machine learning models going in there now, AI bots going in there. And I think next year we're bound to see BI reports and everything getting ended up in there. What's interesting though, is if you're going to put data in a marketplace, it's going to come with a sharing agreement so that consumers, have to agree to the terms of use before they given access to the data, which I think is useful for compliance and auditing purposes and tracking what people do and use data for. So here's an example. You can see how I can produce the data products in a data marketplace. And then if somebody wants to look at which customers are buying which products through which channels, when I can just pick the data products I want and assemble them like Lego bricks, kind of put them in a data mart, for example, and then just access it. And so rather than have to go back to raw data every time, I'm starting with ready-made. And the more I have of these, the faster it gets. And in a data virtualization example, I get a virtual data products accessing these data sources as well as data warehouses and lake houses. I can create these virtual data products, make them available in a marketplace, and then I'll invite others, whether they're business analysts or data scientists, pick what you need and go ahead and use. And of course, because these are virtual, we're not having lots of copies of data everywhere. We're not got a Wild West situation that we saw before. And then they can deliver value. They can take that data, they can build new machine learning models, they can build new dashboards, new reports, even combine data with other data to get new data products. But then when they've built those, they can then, publish those back into the marketplace. And so over time, you're going to get faster and faster at doing this because more and more of what you need, you're going to find ready-made, ready to go. And so shorten the time to value more rapidly. So ultimately, in my opinion, I think what we're going to see is the data marketplace becomes a sort of center of attention for consumers around the enterprise going, well, what have we got? I mean, we're trying to deliver on a strategic business objective up here in a business strategy. There's people at different levels of the business who need to contribute to that objective. And what we need is to give them the right appropriate data products and analytical products that they need in order for them to do their bit, to contribute to that strategic goal and have middle managers and executives also pull on the same rope. So um, the idea being that the marketplace becomes increasingly more important. But we don't need to stop there. I think, as we already alluded, AI can not only, be the receiver of um, of high quality data, but it could also accelerate our ability to building high quality data. So we can use AI to even do that. And of course, generative AI is all over the place already. It's affecting every aspect of data management. If I start on the left-hand side at business glossary and go clockwise, it's speeding up our ability to get things done in a business glossary, to enrich metadata in a catalog, even to generate schema, to do data engineering more rapidly, to be able to do things with data virtualization more rapidly, generate queries, for example, um, even migrate databases, help generate policies to govern our data estate, et cetera, et cetera. So it's already everywhere. and we're going to see much more of it in the next 12 months. Probably one of the most exciting areas for me is large language models come without a knowledge of your data. So how do you get large language models to be able to use and be knowledgeable about your data? And so one way of doing this is to use metadata that you have in a catalog, which of course documents what data you have, and use that to be able to help a large language model know about your data, whether you do it through embeddings or whether you do it through fine tuning, either way, or maybe even both. But nevertheless, this allows us to do things like conversational data search on a catalog to quickly find data. If you're producing a data product, that's going to speed you up. Not only that, but I can enrich uh, metadata, so to curate data, so I can have automatic metadata generation, things like descriptions and stuff like that, of columns and things like that, generating policies, generating data quality checks, all kinds of use cases for this. I can use it beyond data catalog, but as an example of business glossary, I might have a term called claims approval rate. But I don't have a description for that. So rather than wait for somebody to type that in, we could feed it in a prompt and have a large language model generate the description for you, and therefore speed up your ability to explain data. Similarly, while you're scanning data sources to populate a data catalog, you could do the same thing. You could pass metadata into a large language model and have it generate descriptions, and therefore speed up your ability to document what you have so that people can understand what data is available to them out there. I can use it for prompt-based data engineering. So for example, I can, rather than specify technically what to do, I can say in a prompt what you want to do in terms of transforming and integrating data, and have the code generated by a large language model or the metadata specification generated, so that when you invoke that, it's going to produce the data product that you want. So accelerate the process. So if I look at it from this diagram we saw earlier, then you could quite clearly use it in data engineering and in data consumption. So if you're producing data products, then I can do prompt-based data engineering, generate code to create virtual views. Equally, if I'm querying data through virtual views, I could use natural language query. I could even get an explanation of the query using large language models. Or if you typed in your query, you might even want it to check if the query is correct, or if you're having trouble with it, you're not a SQL specialist, for example, you could get the software to do that for you. And then not only that, you could even generate a synthetic data to have it test that out. And then of course on the consumption side as well, it's highly likely that we're going to see natural language user interfaces even when you're looking for ready-made high quality data that's already been produced and available in a marketplace. So that you can either use a natural language, so text-based, tell me what data we've got about something, or alternatively may even end up as a kind of Alexa-style voice user interface. All of that's potentially possible here. So if I summarize that, then I would say if you're a data producer, the whole point of generative AI is it's going to speed us up in producing high quality data in order to provide to other forms of AI, like machine learning, for example. So through conversational data search, through accelerating data curation, potentially schema generation, prompt-based data engineering, synthetic data generation, these are all going to speed up our ability to deliver data quicker. So we're shortening the time to value. Equally, if you're a consumer and you're looking for data, you can get it through conversational data search to find data in a marketplace. You can even have generative AI look at what's available in the marketplace and say, well, actually, based upon what's in here right now, these are the questions we can answer. To give you a quick start, even as a consumer, help you generate natural language queries so that you can then generate the code in the background to actually query this data, get natural language answers back, etc. Even automatic charting, or even if you want to access this as a data scientist from Python, maybe natural language interfaces directly out of your Python code. So it's just all going to speed us up, and so this is an exciting time. We're seeing things that we've done in the past getting faster by using AI, but also that we need high quality data for AI, and data products are accelerating our ability to build a high quality data foundation incrementally, and then give people the data building blocks that they need to go and deliver insights faster. So I hope that gives you an idea of what we could potentially do with all of this. And with that, I'd like to say thank you very much and hand it back to Tammy. Tammy? I think maybe Tammy's on mute.
Hello,
You're on
can you
mute.
hear me
Oh,
now?
here we go. Here we go.
Here we
Here we
go.
go. There we go.
I think my headset decided to have a break. I'm sorry for that.
Okay.
Thank you so much, Mike, for that. So we're gonna have a quick poll. Right at the end, we're gonna do Q&A. There's one question already there, but please be aware you can ask questions in the chat or in the Q&A, and we will take them at the end. So we before we go start with Nick, I think we're gonna go and do a quick question for you. So if you could respond to what should have appeared on your screen, which says, do you have any AI use case involving data managed scheduled within the next 12 months? Now that you heard from Mike, what those use cases could potentially be. And while you're answering that, and we'll give you about a minute to do so, just to kind of point out that Nick's presentation now will actually talk about clients who already have use cases in place and have already put AI and data to good use, and also in regards to how we as a company working towards making life easier for you, really. So that's the next segment of that. So I think in the meantime, Nick, maybe you can already start in the background sharing your screen, and then we'll take that off in about 10, 20 seconds. And I think you can close the poll if you've answered on it. And then we go and carry on with Nick. Nick.
Yeah, thank you. Thank you very much, Mike. Thank you, Tammy. So let me talk from our side about navigating AI and data and about talking about topics like integration of data and also how do we get to reusable data products, which Mike mentioned earlier. And indeed, so some of the things I'm going to talk about some use cases for how data integration helps machine learning and data science. This is actually kind of more traditional applications of AI, and then but still it has some good use cases, but still also a number of unsolved things. And then of course I will switch to a hot topic, generative AI, and here the cooperation between data integration and generative AI goes both ways. So there are great things which Gen AI can do for data integration, but we from the data integration side think that we can do very good things for Gen AI as well. So first, let me start with data integration for machine learning and data science, and talk about some of the example projects which our customers are doing, in this case with data virtuality, and also highlighting some of the aspects which I think are special because it goes beyond the more traditional kind of reporting, or even the by now already more or less traditional building statistical models, but actually also putting this data to work live in real time. and also building a system which is also learning and improving in real time. And here we have a case from financial technology. It's an international payment provider, where one of the services which they provide to their customers who are banks is online credit scoring, but also a sales system for selling loans to small and medium businesses. And in this system, the data are coming from a number of different systems. So it's only 3 shown here, but it's actually much more systems which are gathered internally from different places into data virtuality. And then data virtuality is putting this data to work and to play in many different ways. So on one side, it's getting the data into the playground of the data scientists, where data scientists can build their data models to determine credit risk, to do customer clustering, and so on. It also gives the data into a data analytics system where reports are produced for business people in the organization. And at the same time, it also serves mobile applications via API gateway, which allow to representatives, customer representatives, to go and talk to the customer directly and gather data from the customer and give directly a pre-approved credit directly while talking to the customer. So everything in real time. So the data is getting analyzed in real time using the models which are being created by data scientists, and real-time integration with mobile applications. So this is one example of data and machine learning being put to work in real time. Another example which we have is from the healthcare, and that's actually very, very how can I say this? Well, that's kind of existential use case, really, because here we are talking about optimization of the work of emergency rooms in a network of hospitals. And of course, when I see things like this, that application of AI together with the data, which data virtuality is providing in real time, allows to cut mortality by 10 to 30%, because there's AI system which is able to predict in real time the amount of emergencies and also the availability of the doctors and the emergency beds and the emergency nurses and everything for those patients. So this, of course, a very important result. Second, but still very important, usually it comes first, is also the cost reduction for this network of hospitals is what's important, because in this country, if the patient needs to wait too long, then the insurance does not pay to the hospital for this patient. And of course, there's also important soft factor, less overtime for the nurses and for the doctors, which leads to less stress, lower turnover rates, and better work, because if the doctor is happy, then the patient is also better off. These were the more traditional use cases for AI and ML based on data. They're probably a little bit less hype now, but you see they're really very practically important. And this chapter is not closed. This chapter is not solved. This is not that new as generative AI, but still the topic of providing data to AI projects, to ML projects, is still hot and in many cases unsolved topics, because in many cases, in general, such projects get their data in not the best way. So that's what people are saying on the market, that it's it's a shame sometimes how those data get around to feed those projects. But now let's get back to the generative AI, and let's start with what generative AI can do for us as a data integration vendor. And for us, of course, it's a great thing, because this is something we can use in a lot of places to help humans, which are users of our software, to better interact with our software, and at the end also get better and quicker to their data. So some of the things which we are working on or have on the roadmap are a scale explainer, which helps explain the models inside data virtuality, what are they doing, and especially important to explain such things to new people who start working with the system. There's a dialect translator in Work which translates different SQL dialects in between. A skill troubleshooter, which helps troubleshoot if the query is throwing an error. I would jump on the other side and talk about AI/ML features for integration. So this is not really a Gen AI, but it's still edited here. Schema matching is a topic that for some organizations is a huge topic. They have tens of thousands of tables, they have millions of columns, and sometimes they just need to bring together things to do their report, and this is something which can be helped with AI/ML. There are also some things for working with the integration system itself, for helping building data models inside of data virtuality with AI, and for helping users query data virtuality with AI. But this is something which will certainly require more work, and this is akin to some of the challenges which I will talk about in the next chapter. We will be talking about customer projects. But to finish up this chapter with a kind of something which is more practical. So, for example, this is how our ML. There's a number of ML matchers which help match schemas between each other to create joins or unions. And then there is also a AI explainer which we are building inside of data virtuality, and this AI explainer is explaining complex SQL statements, but it can also explain, for example, existing data models, something like a stored procedure which does some automation. So here I will just do LLM continue its work and switch back to the presentation, because in the next chapter we're going to talk about what data integration can do for generative AI, and this is indeed something very interesting, because this is where we also talk to customers a lot about their projects, and to kind of get more into the history long ago, maybe 9 or 8 months ago, which is a very long in the history of generative AI already. So there was a lot of motion after the first splash of enthusiasm about newer ChatGPT versions, especially less from the practitioners, but more also from the business side, how we can use LLM to kind of directly help us work with data. Why don't we just load all data there and it's gonna answer the questions for us? And I mean, it certainly works to a degree. It's not like it's not possible at all, but there are some huge challenges. So first is the correctness of data. So LLM is a large language model, is a probabilistic model, and the correctness of data, well, 2 + 2 or 2 multiplied by 2 in most cases will be correct. But I remember this entertaining conversation when I was trying to use LLM to check the homework of my daughter. She's in the 5th grade, and we had a very entertaining conversation with ChatGPT about if 648 is divisible by 4 or not. And it took a lot of time. It was entertaining because I had a feeling that I'm talking to a human, but at the end of the day, it was not correct from the AI side. But apart from this, is the data governed? Is it compliant? Is it ethical? Is it unbiased, auditable? And things, and in this case, it's mostly no, practically speaking. And this is where we can improve things by combining 2 engines. One, a quantitative engine, for example, the SQL engine of data virtuality, which is able to answer quantitative questions. and then LLM model, which gets natural language input from the user, from application, and then formulates SQL query for the quantitative engine. And things already get much better here, because here we can ensure data governance. On this interface, we can apply data masking where needed. We can apply permissions for data. We can ensure auditability, so we know what kind of data were asked and when and by whom. But still, this is something which is already helpful in the customer projects. For example, when we are talking about helping internal employees, internal colleagues doing their work, but it's not something which you would normally put out in front of a customer or a partner, because then we also will be talking about things like ethical, unbiased, and also still about the correctness, because although the SQL, the results of SQL query will be maybe correct, not maybe, there's no maybe, it will be correct, but the question if LLM will be able to create a correct query is not necessarily. The answer is not necessarily. And this situation is something which is a work in progress, which many people are trying to solve. So there is a set of challenges running and a set of approaches which are being developed to tackle this. And the current approaches go into the direction that probably we will at the end have not one LLM, but multiple LLMs doing the work for the users and for the applications, where the first LLM will know the domain and will know how to talk to the customer. The second LLM would know the metadata and it would know the SQL syntax. And the third LLM will take care of the things like, are the answers biased? Are they correct? Are they ethical? And so on. And again, this is something which is very much in work in progress. And this is something which we are also happy to support from our side, because to support this kind of projects, data, or we can also say data products, need to be injected in different places. And those data products are also taking different forms. Just like Mike said, it's not necessarily just a data set. And these are also different things. And for example, some of the things we are doing to help customers with such projects is, the simplest thing is building in-context instructions for our SQL dialect, but also working on our own models with embeddings to correctly understand our SQL dialect. So something which can be used here as part of this combination. Also can be fed into a vector DB. So we're also working on metadata export formats to feed the vector databases. And as I mentioned, this is a work in progress, and probably will be more things which we'll be working on over time to support those kinds of projects. So this is all very, very exciting for us. And if you have any questions, please go ahead.
So before we finish with the questions, we wanted to quickly share the results of the poll. So here we have, so most of you have, a small majority have. Several of you said no, and some said I don't know if you have a project. So maybe after Nick's conversation on showing how things could be used in AI, you might have changed your mind. You can do that in the survey, which we share on the general chat. Lucia will share like the link again, where you can kind of give a quick survey response. It will not take you longer than a minute, unless you're a very slow writer, in which case it might take you 2, but not longer than that. So that's in regards to the survey. Lucia, if you could kind of please share that. Perfect. There we go. Now, let's go to some of the questions we have. The first question, I think, is I love the question, actually, goes a little bit away from the topic. It talks about, would AI make the world more sustainable? And I like that, because it's like off field, and I'm just going to throw that at you, like Mike or Nick, who wants to answer that?
I can have a stab at it. For sure it is, of course, because think about, let's just say the energy a company uses. With IoT, we get more and more data about understanding that kind of usage, and therefore we can use AI in order to predict that, ways and, recommend ways in which we can reduce energy or take automatic actions to do certain things. Similarly, as well, even apply that to computing, where we're seeing FinOps, where you can predict better ways in which to do things and reduce the amount of energy you're using in the computing environment, and therefore reduce your costs as well as your energy. I think there are lots of use cases around this in order to, improve sustainability for an organization. And I think it's an exciting new space. In fact, I'm even seeing, if you like, planning applications, even financial planning applications, heavily linked to sort of ESG reporting now and the ability to become more sustainable. So I think companies are using AI to help them become more sustainable, because that helps their brand, which of course is important for customer confidence. So absolutely, I think it's a huge opportunity.
Yeah.
Yeah.
So I would add to this by saying that that absolutely yes, also from my point of view, and that a lot of things about sustainability is more optimized, more sustainable use of the resources which we have in one way or another from the nature. So it's actually about optimization, right? And a lot of things about AI is also about optimization, is about getting more data and about optimizing things. And there are many use cases go towards optimization of different things. And at this point of optimization, it actually matches together very well. So it's about optimizing optimizing the user of resources and optimizing basically how we live and how we use those resources. So yeah, absolutely, yes.
And I'm going to go and say and agree and just give you, like, climate change at the moment is so much data, and it's difficult for humans to really be able to calculate that, and being able to have and digest that with AI and come up with maybe novel ways of dealing with it is also something which at least I hope going forward will be a use case. And I've already seen a couple of things in that direction of companies working to that. So I think AI, yes, will make us more sustainable. AI itself at the moment, I don't think is that sustainable. It's got a big carbon footprint, but I think that will be reduced as we kind of continue working with it, because it's still like up and coming and very new. Is the only other point I want to add to that. Now, but I thought that question was great. Thank you very much. And the other question I wanted to kind of ask, which is a little bit more to the topic, is what do you think is the top use case in AI where DV platform can support? And then I'll come back to the second question on the code, and then we'll have to finish.
Yeah. Well, do you want to go ahead, Nick? You go.
Well, I mean, Tammy mentioned DV, I think, so I kind of took it on me in this case.
Yes, sorry.
Well, so there are actually many things, and many use cases. And I mean, if I just go through all of them, like marketing optimization, cost optimization, like medical optimization, it's gonna take too long. I mean, also Mike had a very broad description, but the King's discipline, I would say, would be just, talking to a system, this kind of natural language BI, but with the aspect of correctness and governance. So this would be like the King's use case. So essentially, that instead of producing lots of reports and lots of evaluations, you just can talk to AI, like to ChatGPT, and you can talk now. The difference, you don't get the good answers, right? So like talking to it like to ChatGPT, but getting real answers which we can use and trust in them. That's actually the King's use case, and we are trying to get there. It's not easy.
So we're actually off time now. It's 6:02. So the one question which we got, we'll respond to by email. So Nick, maybe go to the next slide. So if you need or want to contact us, you can contact us on all of these areas, and Lucia will also share it in the chat. Lucia is also the person who's going to be reaching out to you and sending you the recording, and you're very welcome to kind of come back. And last but not least, please remember the survey. I want to thank again all the speakers today. Mike, thank you very much for giving us such an insight into the AI side of it. I really learned a lot. And Nick, thank you very, very much to kind of give it as well a little bit more flesh and real use cases. I think it really helps to make it a bit clearer in this AI jungle we find ourselves. Thank you for all the people who participated. We hope to hear and see you in the future for other webcasts. And with this, I would close the session for today. Thank you so much.